Hello, I want to cover physics events and collision events in Unity. These are something that we use all the time, and they tend to trip beginners up quite a bit. So I just want to go over a gamut of setup and sort of explain what they're doing, how they work, and common mistakes, most importantly. So I have a scene here. I have a floor with a box collider on it, and I have a ball with a sphere collider on it. Colliders are special components that are attached to the physics system. They have nothing to do with the rendering system. They only deal with the physics system. You cannot see them in the game at all. In order to see your things, you need a mesh renderer. In this case, this ball has a sphere mesh on it, and it has a sphere collider on it. And these shapes are the same. But they are the same conceptually, but they are not the same in practice, in computation. The collider is calculating its collisions with a point and a radius, with a single point and a radius away from that point. While the mesh is a full mesh that is a number of vertices, probably a large number of vertices to make it look smooth, right? So it's not so flat. And that's important because if our collisions were using a mesh collider, it would be way less performant. There is a mesh collider and you can give it meshes, but this is calculating distances between, before optimization, you're basically calculating the distances between every mesh from one object and every vertice on a mesh in one object and every vertice on a mesh on another object. That's sort of the brute force way to do it, to check for overlaps. There are optimizations and things, but mesh colliders are way less performant than physics colliders. Than other shapes. One of the things that means is that if we were to scale non-uniformly, our sphere here can't change shape, right? It's a point and a radius. It doesn't know what direction it's in. It doesn't know what its rotation is. That doesn't matter to the sphere collider. So a lot of beginners will set up something like this, not realizing that it's still a sphere. So keep a lookout for that. It's going to be an issue with sphere colliders and capsule colliders, I believe. On the floor, I have a box collider. Now that we can scale and distort, and it will distort fine. A useful thing to know is you can change the shape of them manually. It doesn't have to. When we create them, it will try to map around the boundary of the mesh that you have attached usefully, but it doesn't necessarily always do that. So you might need to go in manually and adjust it. So we have the ball, and it was not going to do anything though. It's just a shape. It says, "Hey, physics system, I am solid." And physics system goes, "I understand." To make it react, we need to give it a component called a rigid body. The rigid body does a few things. It responds to forces like gravity, and it prevents overlaps. So one of the rules of a rigid body is I do not like overlapping solid things. If I am a solid thing, that's pretty much those two things are like most of physics or physics systems. And it fires off physics events for us to listen to and to use. And that's what this video is really about, but we're still on the setup phase. So with a rigid body, it will move the transform. It will move and rotate the object for us as it sees fit inside of the physics system, which is great. It's important to know that the rigid body will move our object. So if we have a script that's also moving the transform, they will both move the transform at different times, and your game probably bugs out, and it probably looks really jittery, usually, or totally broken. So if we want to move an object manually, we use a thing called kinematic. This video is not about kinematic rigid bodies, but planting the seed of what that word is doing. Anyway, so I've attached a rigid body to the ball, and it will fall, and it will hit the floor and stop moving, which is great. I do not want it to go through my floor. And that is because the physics system will say these things are solid, they will not overlap. And it obeys forces, it obeys gravity. So it will accelerate downwards. The other type of shape entity, I suppose you could call it, that the physics system uses are not colliders, they are triggers. Triggers are different than colliders because they do not consider themselves to be solid, but they still have all of the ability to have the physics system calculate overlaps on them. They just won't do anything about those overlaps. They won't prevent them. And in fact, it uses the same components as colliders. So the trigger is not a sphere trigger component. It is a sphere collider with a trigger checkbox. And now this collider is really a trigger. It's this physics shape in the physics system, literally the exact same shape as the sphere collider, the exact same math and code for that part. But this part says, okay, don't be solid though. So if this is a trigger, it will go right through our floor because you can overlap trigger spaces. The player can be a trigger and the floor could be a trigger. Now the player is solid, the floor is a trigger, and or both, it will still react. Another common mistake is to accidentally remove the collider component, even if you have a rigid body. And of course you will not have, even if this was solid, you would not have a collision, right? You need the collider, the physics needs a collider. There's a bit more about setting up colliders for rigid bodies. The two-sentence version is they will use all of the rigid bodies on them. A rigid body will use all of the colliders on itself and all of its children. So you can add a bunch of colliders together to make complicated shapes that a single rigid body can use. Using child game objects and just combining. You can just have multiple. That looks the same, but extend it downward. So you can have multiple shapes attached to a game object. Okay. And colliders can be triggers or colliders, same component in the physics system, same shapes, but different behaviors. Great. Let's, part one over, that's setup. Part two beginning, now time to talk about the events, the thing we care about, the thing where most of our mistakes are usually made. You've certainly by this point have already seen event functions like start and update, which are functions that Unity will will fire off on our various scripts for us at the appropriate time. We are going to use 6 more event functions that Unity has built into it, and it calls it in the physics update ticks. The physics event systems event functions. The physics event functions are on collision enter, on collision exit. Oops, sorry, we're getting ahead of myself thanks to my IDE's auto completion. And on collision stay. Functions are private by default. We don't actually need to type the word private. Okay. On collision enter, on collision exit, on collision stay, they behave as pretty much what it sounds like. On collision enter, exit, and stay. Let's take a look at our console and just see what these functions are doing. I probably should add the script to my game object, to my ball. I'm going to pause, and we have on collision enter happened once, and now on collision stay is happening over and over and over again. If I unpause, it will probably keep happening. Maybe it's not. doesn't always fire every frame. And then if I make the collision stop happening anymore, on collision exit, it happens once. So enter happens once, stay happens every frame that the objects are touching, until exit happens, and then the objects are no longer in contact. We don't use stay very often. We tend to use enter and exit. You can kind of, you can make a Boolean that's like is touching and set it to true and enter and false and exit, and then in update you can, I don't know, I tend to do that more for reasons, not because on collision stay is bad or wrong or anything, but just like the way the rest of my code is written is probably has a lot of logic in the update loop that I need that variable for. I don't know. Anyway, those are those functions we can use to detect collisions, which is great. It's important to know that they are called for both functions. So if I take this, both game objects in the collision, if I take this component off of the ball and put it on the floor, that's not right. What did I just do? I thought I had it copied. Test. And put it on the floor, and we'll clear my console. The same behavior will happen. On collision enter happened. On collision stay is not happening because I removed that line of code. And on collision exit happens. So it happens for both game objects. In one collision, the events get fired for object A and object B, even though the floor does not have a rigid body. Now, what about if none of the objects have a rigid body? There's no rigid body on the floor, and there's no rigid body on the ball. I'm going to move the script back to the ball and take it off the floor. So it won't obey gravity, but it also won't fire off these events. If I go and make these objects overlap, it's fine. Who cares? Rigid body cares. There's no rigid body here. Okay. So on this function, we need to get some data into it. Let's just focus on the onCollisionEnter function because this part is the same for the rest. When Unity calls this function, it looks for two different versions. It looks for this version, which has no properties, and it looks for a version that has one property of type collision. And it's common practice to name this thing the word other because it's very helpful. So let's open up the documentation for this collision thing. And we can see that it is a struct. It's a data structure. It's a bit of data that has a bunch of subvariables, just a variable with some subvariables like a vector. Vector 3s are also structs. Instead of an X, Y, and Z float values, it has these properties. It has a articulation body. It has a body. It has a collider, contact point, context, game object, impulse, relative velocity, rigid body, and transform. So a lot of these are just references to the things we hit. The transform we hit, the game object we hit, the rigid body we hit, the component, the collider component we hit, and so on. Body and articulation body, those are newer because now there's this other thing in addition to rigid bodies that we can collide with. Don't worry about those. So it's usually a rigid body for us. It also has contact counts and contacts, which are all the different points of contact. Impulse and relative velocity, which are different calculations of the object's relative speeds. Well, relative velocity is quite literally just that. Impulse is the force then applied to one or both of the objects to have them not overlap. Okay. So in this script, we now have this variable with the name other that we can use. And we can change this name to other dot. And you can see here my autocomplete has all of those same variables. And we can just use game object, which has the name property. We can say we hit this object's name. Hello, where's my Unity? There. So this should tell me I'm on the ball. It should tell me I hit the floor. Let me put a rigid body back on the object. And we hit the floor. The ball hit the floor. Because the other thing in the collision for the ball is the floor. And of course, you can probably guess where I'm going with this. We take this script and put it on the floor, not changing any of the code. We just put the script on a different game object. We hit the ball. That says we hit ball. It's probably kind of small. Because the other thing in the collision for the floor is the ball. And that's really useful. Because it means we can write our code and compartmentalize it. We could have a player and a bullet that collide, and the player can be like, ooh, I got hit by a bullet, I should lose health. And the bullet can be like, ooh, I hit anything, I should get destroyed and make a little particle blast. And the bullet doesn't need to check if it hit a player and take away its health, and the player doesn't need to check if it was hit by a bullet or a wall or a hat or a pancake or whatever. And destroy it and make the proper particle effects, right? The player shouldn't be in charge of all the bullet sounds and bullet particles. The bullet should be in charge of all the bullet sounds and bullet particles, which makes projects way easier to develop, right? Player does player stuff, bullet does bullet stuff. We can make different versions of the bullet and make them play different sounds, and player code is the same. And, it's everything's easy, right? When things are nice and compartmentalized and they just kind of deal with themselves. It's called the single responsibility principle. In some circles. Okay. So, another really fun thing to do is to use the relative velocity or the impulse, because their magnitudes will both be larger when the collision was harder and smaller when the collision was softer, and use this magnitude to drive the volume of an audio component before playing the sound of the collision. So in a Collisionenter, you can play like a bonk noise for a golf ball hitting a wall. You can use this magnitude, remap it to some range, multiply it by some number, and then use that to drive the volume of a golf ball sound. Boop, boop, bang, or play different sounds. Checking if it's in different ranges. Pretty easy code to add a lot of juice to that project. Okay, let's now make it a trigger. So this is now a trigger. Same shape, but it no longer cares about. Sorry, my game kind of froze for a second there, right when it was looked like it was colliding. It no longer cares about. It goes right through. Collisions, and there is no Ontriggerenter event happening. It didn't happen. Oh gosh, what are we gonna do about it? Well, we can't use the Ontriggerenter event because there's no collision. Instead, we need to use the Ontriggerenter event. The Ontriggerenter event is just like OnCollisionEnter, except this isn't going to work. It doesn't take the data type collision. It's very common to write some code as a collision and go, oh, oops, I meant to trigger, and then you change this word, but you don't change, and then you get this error. And let's take a look at the error just so we can familiarize ourselves with it. I just cleared the error, I think. This message parameter has to be of type collider. So it doesn't take a collision, which is that data type. It takes collider, which is a component. It is the parent component to the, let me find it, to all of our colliders components, right? So if we go to the collider, collider object, we can see that it inherits from a sphere collider, inherits from collider, a box collider also inherits from collider. It's sort of the parent class, right? Go check out the object-oriented stuff for more about inheritance. But all of our colliders are of type collider. So it's a reference to the component that we are overlapping the other one. And a collider component, being a mono behavior, has a reference to game object, has a reference to transform, and we can use get component to get, anything else we might want. So it also, its name is other and it has a reference to game object. So entered the space of, so that code works, should work. we entered the space of 4, right? Great. Amazing. It's very common to do things like compare tag inside of an if statement. This is a pretty common pattern, is to have an onCollisionEnter or onTriggerenter and have check what tag we hit. Did we hit a bullet? Did we hit an enemy? Did we hit a deadly item? Right? You know, I had a game where I had spike traps and I had boulders that rolled on you and I had all sorts of stuff. But all of them had the same tag, which was kills you. I think I called it death. Okay. So common mistakes with this are that. Gosh, more than anything else, I think I see that. We misspell the word collision. It has 2 L's. Highly recommend making sure your IDE, your code editing environment, your integrated development environment, IDE, is properly set up to give you those autocompletes. In Writer, what's the button? In Writer, there's generate code. Where are you? Alt insert. I knew that. Generate in the event functions. And you can go and I'm gonna need a onCollisionEnter. And blah 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 blah, you know. And it will create them for you. It's nice to do it all with a keyboard. It needs less typing. Okay, other common mistakes happen when we go from 3 dimensions to 2 dimensions. A very common mistake is, so let's head to this 2D example scene. And remember, we don't give our objects rigid bodies, we give them rigid body 2Ds. And they don't have box colliders, they have box collider 2Ds on them, which I need to add. The 3D physics system and the 2D physics system, let's add our test to this object, are separate physics systems. One operates in 3 dimensions, one operates in 2 dimensions. They behave very similarly, but they are 2 separate systems. If we go to your project settings, we can see that. We have a physics tab with all the settings for our physics system. We have a physics 2D tab for all of our settings of our physics 2D system, including gravity. That's where you change it. So we do not, it does not, the 2D physics system does not fire off onCollisionEnter. It fires off onCollisionEnter 2D. And it does not take a collision component. It takes a collision 2D type. Ontriggerenter 2D and collider 2D. So the short version is you have to remember to add that 2D suffix to all of your 2D physics. And it's such an easy mistake to make. Why didn't I do anything? Because the code doesn't do anything. Load. There we go. I think that's more or less everything I want to cover with the physics system. It's just so easy to make little mistakes and get tripped up. So easy to not realize you don't have a collider attached to an object, or that the collider is actually a trigger or is not actually a trigger, or your collision event is named incorrectly, or that there's no rigid body involved and you're moving things without rigid bodies. If you want to move a rigid body but have it behave with physics, you can make it kinematic. Not in scope of this video, but that's the main stuff. That's the there you go. That's all I got. All right, thanks.